Okay, let's continue on in example 1, part C. And before I determine algebraically if this function actually has an inverse or if it's one-to-one, I'm going to ask you to state the domain of this function. So remember, this is an even root function, and I'm going to set the argument greater than or equal to 0. This one you can get x by itself. Okay, it's a linear inequality, and you're going to get x is greater than or equal to 2. Okay, so the domain of this function is x is greater than or equal to 2. Now, if I were to ask you to figure out the range, right? So let's just verify this graphically right now. This is basically your even root function. If we want to think about transformations, right? Shifted, 8 units to the right, but a horizontal stretch, horizontal shrink by a factor of 1/4. Okay, but if you were to actually plot this, what does this graph look like? It's going to look something like this. Because x is greater than or equal to 2, the function is going to look something like this. Okay, so 2, 0, right, is your starting point. And so the range of this function, right, is y is greater than or equal to 0. Okay? All right, so I'm going to go back and actually this should be a 2 right here, right? I factored this incorrect. Let me just quickly erase that there so you don't get confused. This should be a 2. Okay, so that's what the graph looks like. That's the domain and range. What am I asked to do over here? I'm asked to determine, right, if it's one-to-one. Okay, so I need to check when f of a is equal to f of b, right, does a equal b? So plugging in, I'm going to get 4a minus 8 is equal to 4b minus 8, right? If I plug in f of b, if I square both sides, you can clearly see that I'm going to get 4a minus 8 is equal to 4b minus 8, right? These guys are going to cancel out. 4a is equal to 4b. You're going to get a is equal to b, therefore 1-to-1. Okay, so this is a 1-to-1 function because for each output of y, I only have exactly one input. Now, this is clearly going to pass the HLT, right? It passes the HLT, so we already did part 2, which is the verify graphically. And then part 3, we have to actually find the inverse. So if the inverse exists, right, we actually have to find it. So again, right, I'm going to switch my x and y values. So this is x is equal to square root of 4y minus 8. And I need to get y by itself. Okay, so square both sides. You're going to get x squared is equal to 4y minus 8. Add 8 to both sides. Right, and then divide by 4. You're going to get x squared plus 8 over 4 is equal to y, but then make sure you call it f inverse. Okay, now, before you box your answer, this is important, okay? If the domain of the original function is x is greater than or equal to 2, that means the range of the inverse is y is greater than or equal to 2. And likewise, if the range of the original function is y is greater than or equal to 0, that means the domain of the inverse has to be x is greater than or equal to 0. And this is why I went over domain and range in the beginning. Okay, this is why you need to know how to find the domain of an even root function. So all this material, it adds up, okay? And if you think about it, if I don't write this restriction right here, right, this is x squared plus 8, right, it's basically 1/4 x squared plus 2. This is not going to pass the horizontal line test, right? The inverse itself also needs to pass the HLT. But if I restrict the domain for x is greater than or equal to 0, it will pass the HLT. Okay, so I'm going to talk about domain restriction in the next video or so. But for now, make sure you write x is greater than or equal to 0. Okay, and if you don't, right, you'll maybe lose 1 point on a quiz or a test. Okay, speaking of domain restriction, take a look at part D. I'm going to allow you guys to skip the algebra as soon as you see the domain restriction, because if I plug in f of a and f of b and try to get a and b equal, it's just a little complicated trying to explain that, x is less than or equal to 2. And actually, this function is 1-to-1 because if you graph it, right, let's just start with the graphical part. This is a parabola shifted 2 units to the right. Again, normally I would graph this across the whole page, right? This is my parabola. Clearly it's going to fail the HLT, but notice this domain, right? This is the domain restriction, is x is defined for less than or equal to 2. So what that means is I only want the left side of the graph. Oops. Let me try that again. That means I only want the left side of the graph. Okay, so I erased the right side, right, because x is less than or equal to 2. So now you can clearly see, right, this will pass the HLT. Therefore, 1 to 1, therefore it has an inverse. Okay, so the domain is x is less than or equal to 2. The range, right, you can see is y is greater than or equal to 0. So it's always helpful to write the domain and range of the graph. So again, on this one, you don't have to verify algebraically. Okay, I'm not going to expect you to do that in the homework or on a quiz or test. Okay, all right. So if it has a function, if it has an inverse, let's actually find it, right? So again, I'm going to switch to x and the y, and I need to get y by itself, right? So if I take the square root of both sides, you got to be careful here. You're going to have plus root x or minus root x, right? And so you're going to have two equations. You're going to have root x plus 2, or you're going to have negative root x plus 2 is equal to y. And this is where we have to figure out our domain and range of the original function, right? The domain of the original function is x is less than or equal to 2, right? That means the range of my f inverse, right, for f inverse has to be y is less than or equal to 2, right? And if the range of my original function is y is greater than or equal to 0, that means the domain, right, for my f inverse has to be x is greater than or equal to 0. Okay, so now which one of these functions do I actually select, right? Because y is less than or equal to 2, right? Y is going to be pretty much negative, right? I'm going to select this one right here. Okay, so this is my actual f inverse. F inverse of x is negative root x plus 2. This is the correct function, not this one, because y is less than or equal to 2. This function will make my, y value is less than or equal to 2 if I plug in. Okay, so this is why it's important that you understand domain and range. And clearly on this one right here, right, it's going to pass the HLT. And actually, if you were to graph this, right, this is your square root function that's reflected across the x-axis, right, and then shifted 2 units up, okay? So shifted 2 units up, and it's going to look something like this in case you want to graph it, right? Shifted 2 units up, square root function looks something like... something like this, okay? So it should be a reflection across line y is equal to x. I know that was a poor drawing, poor attempt, but that's what it looks like. Okay, so on the very last example, I want you guys to try this and maybe perhaps pause your video and see if you can verify algebraically first, and see if you can find the inverse if it exists. Okay, so try this one, and pause the video and see what you come up with. Okay, so hopefully you had a chance to try. Again, to verify algebraically, plug in a, f of a. You're going to get a plus 1 over 3a plus 2 is equal to b, f of b, b plus 1 over 3b plus 2. All right, so for a problem like this, right, you can do a little cross multiplication. So let's do that right here. A plus 1 times 3b plus 2, right, is equal to, 3a plus 2 is multiplied by b plus 1. Okay, so you're going to have to do a little foiling here. Let's do that. If I multiply over here, I'm going to get 3ab plus 2a plus 3b plus 2. So that's the left side FOILed. Over here on the right side, I'm going to get 3ab plus 3a plus 2b, right? And then plus 2. Okay, so a little bit of foiling, but you can see that these 3ab's cancel out. These 2's are going to cancel out, right? And over here I have 2a plus 3b is equal to 3a plus 2b, right? And so if I move this 2a over, I'm going to get a. If I move this b over, I'm going to get b. Okay, so therefore it's 1 to 1. Okay, so the algebra looked a little bit intimidating, but really you're just foiling. It's 1 to 1. Okay, so if it is 1 to 1, right? If you want to verify this graphically, again, I haven't reviewed graphing rational functions with you just yet. It's going to look something like this. Okay, you can use Desmos for now, but roughly it's going to look something like this. Rational function. Okay, it's going to pass the HLT. Again, you can use Desmo. I'll review how to graph rational functions with you later. Okay, the very last step, right, is algebraically, I now need to find the inverse because I know it exists, okay? So algebraically, right, we need to switch this. We're going to call this x is equal to y plus 1 over 3y plus 2. And again, this is really an exercise of practicing your algebra skills, okay? So how do I get y by itself? Well, you're going to have to do a little cross multiplication. So x times 3y plus 2 is equal to y plus 1. Again, distribute. You're going to get 3xy plus 2x is equal to y plus 1. To get y by itself, I'm going to move the y over, and I have 1 minus 2x. Between these two terms, I could factor out the y. I'm going to get 3x minus 1 is equal to 1 minus 2x. And I can divide by that factor. Y is equal to 1 minus 2x over 3x minus 1. This is my F inverse. Okay, so hopefully you got a chance to see what I did over here, both algebraically